Welcome you all. Myself Prabhakaran, belongs to Physics Department. In this session, we are going to discuss the crystallographic terms in crystal physics. Before starting, let me have a small quote by Albert Einstein. Imagination is more important than knowledge. In the middle of difficulty lies opportunity. Introduction of crystal physics. What is the necessity of studying crystal physics? Crystal physics says the structure of the materials. If you know the structure, then we can able to know the behavior of the material. All matters in this universe exist in three forms: either solid, liquid, and gases. Materials differ from one another because of their differences in their properties. All the materials are composed of atoms and molecules. We know that some solids are brittle, some are ductile, and so on. The reason for these different properties of the solids are due to their structures. That is, the behavior of the solid materials is closely related to the structure of the material. Now, let me discuss the classification of solids. The solids can be classified into two categories, namely crystalline and amorphous solids, that is non-crystalline solids. Crystalline solids are those in which atoms or molecules are arranged in a regular order, in a periodic manner. Then we can call that as a crystalline solids. Crystalline solids in which the atoms or molecules are arranged in a regular order in a periodic manner. Then we can call that as a crystalline solids. Example: copper, silver, aluminium, etc. Non-crystalline solids or amorphous solids means the solids in which the atoms or molecules are not arranged in regular order. The solids in which the atoms or molecules are not arranged in regular order. Example: glass, plastic, rubber. Please look at the diagram which I have shown. Crystalline solids, the atoms will be arranged in a regular order, but in amorphous solids, the atoms does not arrange in a regular order. Now, let me discuss the difference between crystalline solids and amorphous solids. The atoms or molecules are arranged in a regular order in 3 dimensions, then we can call that as a crystalline solids. Whereas, if the atoms or molecules are not arranged in regular order, then we can call that as a amorphous solids. When crystalline solids are broken, even the broken pieces will have regular structure. But when the amorphous solids are broken, the broken pieces will not have a regular structure. They have sharp melting point. Crystalline solids always have sharp melting point, but amorphous solids does not have any sharp melting point. The property of the crystal is different in different direction, so that only crystalline solids are anisotropic in nature. But the property of amorphous solids are same in all direction, so that only amorphous solids are called isotropic in nature. Example for crystalline materials: copper, aluminium, silver, etc. Example for amorphous material: glass, plastic, rubber, etc. Now, let me discuss some of the basic crystallographic terms, because it's only helpful to understand the concept of crystal physics. The first smallest definition is lattice. Lattice means nothing but the arrangement of atoms in a crystal, that is in a material. The arrangement of atoms in a material is called as a lattice. The next one, lattice point. The position of atoms or molecules are represented by a point. The position of atoms or molecules are represented by a point. Then we can call that as a lattice point. In order to draw the atom, simply if I specify a point, then it is called as a lattice point. Space lattice. An array of lattice point in 3 dimension. A group of lattice points in 3 dimension, then we can call that as a space lattice. The next important topic is unit cell. Unit cell is the smallest volume of the crystal, and by repeating this in 3 dimension, we can get the entire crystal structure. Unit cell is the smallest volume of the crystal, and by repeating this in 3 dimension, we can get the entire crystal structure. Please look at the crystal lattice. In that crystal lattice, have a number of unit cells. Okay, I have specified the diagram a separate unit cell. So crystal is made up of so many number of unit cells. Please look at it. I will give some more example to understand the unit cell. The wall is made up of bricks, we all know. Likewise only, the crystal is made up of unit cell. The shape of the wall depends upon the shape of the brick. Like that only, the shape of the crystal depends upon shape of the unit cell. The property of the crystal is the same as that of the property of the unit cell. I think you have got enough understanding explanations regarding unit cell. Next one, types of unit cell. The unit cell can be classified into 2 categories: primitive cell, non-primitive cell. Primitive cell means the unit cell contains lattice points only at the corners. Unit cell contains lattice point only at corners, then we can call that as a primitive cell. Or otherwise, unit cell contains only one lattice point per unit cell, then it is called as a primitive cell. Example, simple cubic unit cell. Non-primitive cell means if there are more than one lattice point in a unit cell, it is called non-primitive cell. If there are more than one lattice point in a unit cell, it is non-primitive cell. Example, BCC and FCC. BCC means body-centered cubic system. FCC means face-centered cubic system. Please look at the first diagram. It is a simple cubic cell. It has atoms only at the corners. But at the same time, if you look at the second and third diagram, in addition to corner atoms, there will be an atom exactly at the center of the body as well as exactly at the center of each faces of the body. Then we can call that as a non-primitive cell. The first diagram indicates primitive cell, the next 2 diagram indicates non-primitive cell. Thank you all.